Hello guys, welcome to my YouTube channel. In our today's video we are going to look at science paper 1, specifically 2022 for internal candidate. Yes, so we are going to solve section B, question 9. So here are the just quick questions for question 9, and then here I'm going to write the answers for these questions. So the first one we have A Roman numeral number 1 is saying define half-life. So as half-life, this one is half-life. So now as for this one, we can say half is like this. As you can agree with me, this one is what? Half. And then the life. Now let's say, for example, for us to define this one, let me just explain it a bit so that you understand. So let's say, for example, if we have 8 grams, okay. If we have 8 grams, or let me say you have 12 years. From now, you have 2 years. Let me say you have 12 years. So after 12 years, let's say for example, after 12 years, you are going to die now. Now, how are you going to know your half-life here? So your half-life here, we can say, for us to know the half-life of 12 years here, we are going to say 12 multiplied by 1 over 2. Since this one is half, then the answer here, we are going to get 6. So we can say this 6 here is the half-life. Now this 6 here, it is coming from the original years that you are remaining with. Okay. So for us to define half-life, we are going to say it is the time taken for the original mass of a substance to be reduced by half. So we are going to say time taken for the original mass to be reduced by half. So that's the word D, the correct definition. So here we are saying the half-life is defined as time taken for the original mass to be reduced by half. So according to the space that they were given in 2022, this definition can suit, okay? Yeah. So be mindful when defining. So you need to check the space that you have been given. So according to this one here, this one can suit. So let's move on to the next one. So the next one is saying iodine, let me say iodine 132, which is represented by capital I, decays by emitting a beta particle to produce a new element, hexane, which is hexane Xe. So this symbol here, it is for the hexane, and a gamma ray. Okay. So as you can see here, so I'm going to write as the Roman numeral number 2, this one. Then this one is Roman numeral number 1. So the first thing here, they have given us this information here. Now let me read the question. The question is saying write an equation for this decay. So for us to write an equation for the beta decay, the first thing here we need to know the general equation for the beta decay. So let me give you the general equation for the beta decay. Let's imagine if this one here is the element. We are going to find that if this element undergoes beta decay, then this symbol here is going to represent the mass number, or we can say the nucleon number. Then Z here is going to represent the proton number, or we can say the atomic number. Now let's have an example. If this one here undergoes beta decay, we are going to find that this parent nuclide, this one here is going to be our parent nuclide. This parent nuclide is going to form the daughter cell. Okay, we can say, let's say for example, if this one here is the daughter nuclide, which is the daughter cell. So here I'm saying, if this X undergoes beta decay, we are going to find that a daughter nuclide is going to be formed. Now, what usually happens here is that during the beta decay, the mass of the daughter cell is going to be added by 0. Are we together? Yes. Then apart from this one here, the proton number or the atomic number will be added by 1. Then here I'm going to say plus the structure or the nature of an electron. So one thing here, what you need to understand here is that as for beta decay has the nature to that of an electron. Now since here we know that electrons are negatively charged, which means the beta particle which is this one, this symbol here, it is also negatively charged. Okay, so this one is also a property of a beta particle, negatively charged. A beta particle is negatively charged because it has a nature to that of an electron. Okay, so since here I'm saying it, the proton number or the atomic number will be added by 1, then the mass number or the nucleon number will be added by 0 plus the nature of an electron. Now, according to the information here that we have been given, this one here they are saying iodine. So iodine is going to be our Xe. Instead of writing X here, we are going to put iodine, which is 132. So I'm going to say iodine 132 iodine. Then the electron number, which is 53. So now let's imagine if this one here, iodine, is the parent nuclide. We are going to find that if this one undergoes beta decay, we are going to find that the particle, which is hexane, which is Xe, is going to be produced. So hexane, which is Xe, is going to be our daughter cell. Now, like I was saying here, the mass number will be added by 0. So if we add 132 plus 0, the mass number or the nucleon number is going to remain the same. Now what about the proton number or the atomic number? So since here I'm saying the proton number or the atomic number will be added by 1, so here I'm going to say 53 plus 1, then here I'm going to get 54. So the proton number has been added by 1. So here I'm going to say, now, as you can see here, they are saying iodine 132 decays by emitting a beta particle to produce a new element hexane, which is Xe, and a gamma ray. So here I'm going to say plus the nature of an electron. Since I know that this one here is the general equation for the beta decay, so I'm going to say plus the nature of that of an electron. Now, they have also included this one here and a gamma ray. Here I'm going to say plus gamma ray. Plus gamma ray, which means here I'm done. Or if you want, you can also put plus energy at the end. So it's mass also, you need also to put energy. So here I'm going to say iodine 132 decays by beta particle to form hexane, plus the nature of an electron, plus gamma ray, plus energy. So remember, during beta decay, the mass will be added by 0, then the proton number or the atomic number will be added by 1. So this one was just a general equation. So if they say writing the equation for the beta decay, don't like this one. This one is just a general equation where X is iodine here and Y is hexane. Okay. So let's move on to the next one. So the next one, which is the Roman numeral number 3. So Roman numeral number 3 is saying, give one property of a beta particle. So like the way I was saying here, a beta particle has the nature to that of an electron, and an electron has a negatively charged. So which means even beta particle has a negatively charged. So we can say it is negatively charged. Negatively charged. So let's continue. B. Roman numeral number 1 is saying, give one medical use of radioactive substances. So the first thing here we are going to say, it is used in the treatment of cancer. It is used in the treatment of cancer cells. So that's the word T, the medical use. Then the last one is saying, explain the effect of radioactive substances on the environment. So the last one here I'm going to say the effect of radioactive substances on the environment is that they cause what? Or it causes pollution. Apart from causing pollution, we can say health hazards. Health hazards. So apart from health hazards, we can say change in climate. Change in climate. So on this part here, just choose only one. Thanks for watching. See you next time. Bye bye for now.